Hello everyone, welcome to Engineering and Economy. I'm Dr. Nathan. Today we are going to look at the lesson 5 of the series of investment planning for renewable power generation. So today we are going to look at the internal rate of return. This is another indicator. Last few weeks we have been looking at net present value technique NPV techniques to make investment decision. Now we are going to look at another indicator, that is internal rate of return IRR, to decide whether to invest on the project or not. So internal rate of return is the interest rate that makes the net present value zero. So this is the interest rate that makes the net present value zero. Zero means is a balance condition, whether there's no profit or there is no loss. So in essentially what is we are going to do, we are going to find the balance condition for what interest rate your investment going to be balanced. So this is why we are doing this, means like uh, interest rates are not always constant. We in some countries interest rates are fixed, like United States, the currency values depreciate by 2% per year. We can trust on that 2%. In Australia, it's about 1.5 to 2.5. We can trust on those numbers. But countries like Sri Lanka and some other developing countries, because of financial crisis, we cannot trust on the discount rate. So if they say 10 percentage, government say 10 percentage, how we can trust? Because next, after a few months, we have a crisis or economic problems, the money value keep on reducing, so it's difficult to trust on that interest discount rate. In those kind of situations, we have to go with the internal rate of return, and then we can find the reasonable guess what whether we can invest on the project or not. Okay, before understand the purpose, let's look at one calculation. So the question is, invest rupees 9,000 now, receive 3-year payments of 2,500 each, plus 4,000 in the third year. Find IRR, internal rate of return. So question is very simple, like what we did in last few lectures. First thing, we have to find the data. What are the data here? Investment is 9,000, first data, and the number of period is this n equal to 3, and first year revenue, the second year revenue, and the third year revenue. Third year we have 2 revenue. That's a simple thing. So this, as a second step, we have to, this is the first step, we always do this, because when we do this, then that we say given data, break down the sentence into a mathematics form. This is a mathematical format. Now second thing is we have to uh, come into accounting part, that is putting the cash flow diagram, because in accounting we have to put the cash flow diagram. First thing, that's part is the investment going 9,000. There's a down arrow because it's going out of our pocket. What is the revenue? The first year we are getting 2,500, and the second year we are getting another 2,500, and the third year we are getting 2,500 plus 4,000. So now we understand the question. Now we have to find IRR. IRR, like what value going to make NPV. We can find the NPV from last few weeks lectures. We can simply find the NPV. This is a zeroth timeline, so we bring everything to here, to PV1, then make it this one to here, to become PV2, then it become here, bring to here, and PV3. And if we add everything, NPV equal to minus 9,000, because 9,000 is investment, plus PV1, PV2 plus PV3. How we find the PV, present value, that we can apply the equation. The future value, FV1, 1 plus r to the power n. Likewise, we can add the equation and find. It's a very simple thing. But today we are going to find, not we are going to find this one. We're going to find the IRR. So we go with the table like for 10 percentage, because this in this case there's no certain methods to find it. We had to assume first thing, we assume the discount rate at 10 percentage and do the NPV calculation. As I explained earlier, we find the NPV calculation. The present value PV1 equal to FE1 1 plus r to the power n. Likewise, we can factor it 1 plus r to the power n multiplied by FE1, future value 1. So that is a case here. This is n equal to 0, present value. This is n equal to 1, n equal to 2, n equal to 3, n equal to the same 3. Okay, because this is also n equal to 3 because we have a 2 revenue in the third year. N equal to 3, sorry. So these are the cash flow. So this is a future value 1, future value 2, future value. This all together become future value 3. Okay, these are the factors. This is the factors 1 over 1 plus. Here we take 10 percentage, so 0.1 to the power 1. Likewise, these are the factors. This is the present value 1, present value 2. These are the present value 1, present value 2, and these together become present value 3. So when you do this normal NPV calculation by assuming 10 percentage, we got 223, 2.39. So this is not 0. Our target is to make this as 0. Target is to make NPV 0. So that means if we make NPV 0, that particular discount rate will become a IRR. So what discount rate going to make NPV 0? That particular discount rate is IRR. So we definitely got the positive. This is here NPV equal to greater than 0. So next step we try to increase the discount rate. Now we increase to 12. Let's see what happens. When it apply 12 percentage, this is R equal to 12, I mean 0.12. Then we do the same calculation, same method. Then we find the negative 148. So NPV less than 0. So this is again is not equal to 0. So this is NPV not equal to 0. We want to make NPV 0. So this is not, so this is going extreme end. So now we understand the discount rate should be between 10 and 12, because earlier we put 10, it's become positive, 12 become negative, so it should be between 10 and 12. So let's assume another value is like 11.2, because we had to put different values like 11.1, maybe 10.9, all the values we had to put, because I don't have enough time to explain each and every number. But if you put in the Excel sheet, you can easily do it with different values. You can easily do it in the Excel sheet. You can find the answer. So here when we put 11.2 and when we find the IRR, it's become 0. So IRR is equal to 0. Why? Because for R equal discount rate equal 11.2 percentage, NPV becomes 0. So what is the idea here? Now why we are doing this? Because let's say if I do not know exactly, for some project, some countries, we don't know what is exactly discount rate. Now what is my message from this statement? What is my message? Even if the currency lose the value by 11.2 percentage, my investment become balanced. I'm not going to lose the money. I'm also not going to gain the money. So if I have a reasonable assumption that the discount rate, I will go to bank and ask whether the country's economy going to be losing, or what is the discount rate you are expecting next year. If the bank says that next year discount rate will be 10 percentage, I'm happy. I will say go for this project, because I know even if we have 11.2 percentage, we are balancing the NPV. It's like a safe zone here. It's 11.2 percentage is a safe zone. If we are not making any revenue at the profit at 11.2 percentage, but this is a break-even point. We say break-even point. There is no profit or loss. But we go to the bank and ask, like maybe in last 2 years during the crisis times, economic crisis in Sri Lanka, we go to the bank, ask what is the discount rate. They say it's like 15 percentage. Then we reject. Why we reject? Because we know that if it is 11.2 percentage, is a balance condition. If we go higher, earlier we understand, if we go higher, if we go to 12 percentage, what happens? We got minus 148. So NPV negative. NPV negative for 12%. Even for 12% NPV is negative. So we don't want to accept this project. For these kind of situations, when we are not very sure about the discount rate, then the IRR method is more suitable, because we find the IRR, then with the IRR value, that is 11.2 percentage, then we analyze whether my currency value going to lose more than this amount. If it is going to lose more than 11.2 percentage, I will not accept the project. If it is a currency value is depreciating less than this amount, this percentage amount, then we will accept the project. So that's this is understanding of internal rate of return is the discount rate that makes the net present value is zero. In other words, it is the expected component annual rate of return that will be earned on the project or investment. Okay, that's all for today. Please subscribe this channel. Thank you very much for watching these videos.